So in this second lesson of 5.2, I'm really kind of doing a review lesson. I want to talk about solving differential equations, which was absolutely a topic from Chapter 4. It's something we did in Chapter 4, and again, part of the reason I'm reviewing it now is it didn't go very well on the test. Some of you really missed the simple question about solving a differential equation. The one I'm doing in this video is going to be related to the natural log thing we just learned. So it is kind of new, but it's also review stuff. I want to quickly cover what the steps are in solving a differential equation. So I suppose first we should look at one. This isn't going to be the one I'm going to solve, but just as an example, if we have dy dx equals x squared minus 4, what are the steps in solving that differential equation? The first step is basically separating the variables, which for right now just means multiplying that dx over to the other side. At this point we've got something like, dy equals x squared minus 4 dx. So what's the next step? The second step is that we're supposed to take the antiderivative of both sides, right? So that's where you sort of put the integral on both sides. So for our purposes here, on the left side, this antiderivative ends up being y, and on the right side, it ends up being 1/3 x cubed minus 4x plus c. And step 2 is really where the complexity happens, right? This thing over here may require u substitution. It may require us to move things, or it may require all kinds of stuff. So really that's where all of the work is going to happen. And then step 3 is potentially an optional step. You may remember that this thing here was called the general solution. If you want the particular solution, you need to plug in a point that's given and find the value of c. So that's step 3. Okay, so that's our overall process on solving differential equations, right? We separate variables, we take antiderivative of both sides, which is the step that requires all the work, and then if you need a particular solution, plug in the point that's given and find that particular value of c. Right? So now I'm going to go on to the actual sort of new problem. So here I want us to find the particular solution to this differential equation that passes through the point 3 comma natural log 10. Right? So as we just covered before, the first step is multiplying that dx over to the other side. So now I have dy equals x over x squared minus 4 dx. Now that I've done that, I'm supposed to take the antiderivative of both sides. That's step 2. The left side is easy. It's always going to be easy. You've got y equals, and then I have to deal with this, right? This is not a simple integral. This isn't something that's just like, oh, whatever, this is easy. We're going to have to take at least a couple of steps here, right? I don't know what that integral is offhand, so I'm going to have to do some sort of an algebraic manipulation or a substitution. In this case, it makes sense for me to use u equals x squared minus 4. At this point, you may actually want to practice this one on your own if you'd like to try it, or you can watch me go through it. Your du here is 2x dx, which means du over 2x equals dx. So plugging this stuff in, this is the integral of x over u times du over 2x. This works out really nicely for me because there's an x on the bottom and on the top. And so notice I'm really trying to write down step by step what's happening here. Right? The left side is still y. The right side I still haven't taken an integral yet, so this is 1/2 the integral of 1 over u du. And I'm just kind of following through this. I'm doing what I'm supposed to do. This is now y equals, now I'm ready to take this integral, 1/2 the natural log of the absolute value of u plus c. And at this point, I've completed step 2. Remember, step 1 was multiplying the dx over. Step 2 was take the antiderivative. I'm basically done taking the antiderivative. All I need to do is plug u back in. So if you remember from my substitution before, u was x squared minus 4, so that's what I'm going to plug back in. I now have y equals 1/2 the natural log of x squared minus 4 plus c. This thing here is that general solution. If we want to find the particular solution, which we do, we have to go on to step 3. And step 3 basically means that we're plugging in our value, right? So the value we were given in the problem was, the point that was given to us was the point 3, ln 10, right? I'm going to check that really quickly. It's not up. That's okay. 3 natural log 10. So let's see here. I'm going to have my ln 10 on this side equals 1/2 the natural log of 9 minus 4 plus c. And note, my only goal here is to find that value of c, right? So this is ln 10 equals 1/2 ln 5 plus c. So if I want to find c, I'll have to move that thing over. This is ln 10 minus 1/2 ln 5 equals c. And so it's like, okay, so technically that's the value of c. I suppose I could just take this and plug it in right up here. But this is kind of a mess, and we've had training on this before. I should be able to simplify that. I should be able to do something with that, and we can, right? There is a subtraction here, which means I can divide the things inside the logs, but first I have to deal with this. This is ln 10 minus ln square root of 5 equals c. I think the problems that I have the assignment for this are actually simpler than this one is, but I wanted to pack a lot into this one. So I can simplify this and make this the natural log of 10 over root 5 equals c. And I know a lot of times I don't have you guys rationalize these things, but in this case I'd kind of like to do it because I think it's going to be pretty. If I multiply top and bottom both by root 5, I'll end up with 10 root 5 all over 5, which simplifies to 2 root 5, which is pretty nice. I end up with the natural log of 2 root 5 equals c. And so that means my particular solution is y equals, and we should scroll back up, hopefully this thing has a log of what it is. Yeah, oh, sorry, there it is. This 1/2 natural log x squared minus 4, 1/2 the natural log of x squared minus 4 plus the natural log of 2 root 5. Right. There are a couple more things we could do here. I feel like I should probably stop while I'm ahead or less behind. I'm going to put a box around this, but then I'm going to take a few more steps just to show a few more things if you're interested. The first one is actually really important. So if you haven't stopped the video, one of the most important simplifications is to recognize that a 1/2 means a square root. So we could very well have the natural log of the square root of the absolute value of x squared minus 4 plus the natural log of 2 root 5. This answer is actually better than the previous. I don't know that I'd really call it better, but it is really important that you guys recognize a half in front of a natural log means a square root. The other thing I was going to say, and this one is really pushing it, is that I've got a natural log plus another natural log. There's really no reason that I can't smash those things together. That I can't call this the natural log of 2 root 5 times the square root of x squared minus 4. But if I'm going to go that far, why not say this is the natural log of, remember we can take this 2 and move it in by calling this the square root of 20. And the reason I'm doing that is that we could make this the natural log of 20x squared minus 80. So it's sort of one of those things where it's like, wow, this whole thing could actually be compressed down into one natural log. I don't think you guys are going to have problems that require you to do that with things that are like this. But for those of you that are interested in what's possible, for those of you that see math as the playground like I do, of like, what can we do? How can I move things around? This is one of the things that can be done. And it's always valuable to see those things and know about them. But know that any of these boxed answers is totally acceptable as a free response answer. Multiple choice, you're going to need to match whatever I've got there, but these are all things that can be done. That's all I have in this one. The last video is a really short thing. It really just covers some more things you guys have to memorize. So we'll see you in that video.